All right, gang, I'm going to start to quickly work through this Chapter 4 review. If at any time you don't understand something, let's talk and try to figure things out. So I'm going to do this really quick. Hopefully you've got most of it laid out already. So here you go. Taking a look at the first section, okay. Sum of the interior angles of a triangle add up to 180 degrees. So I'm going to take 180 minus 125 gives me, what is that, 55 degrees. Okay. If that is 55 degrees and that's 62 degrees, if I take those and subtract them from 180, 110, 117, so that would be 63 degrees. Okay, 180 minus these two. 125 and angle 4 are vertical, so they are going to be the same. Okay. And then if I take 125 and 32, that's 157 from 180, gives me 23 degrees. Okay. In this next one, notice how things are set up here because that's important. Angle R is congruent to angle X. So as I look at that, I can set those two equal to each other. And then I can go ahead and solve for y. So if I subtract 3y, if I add 10, y is going to be 15 degrees. Okay. For x, I see that RT would be this segment here, so XZ would be the same, so I can set those equal to each other. Okay, so I'm going to subtract x from both sides, and I'm going to add 14. And so x is equal to 35. Okay. To figure out the value of x, I know that these angles are both congruent to each other. Remember, they're opposite the congruent sides. So 180 minus 116 would give you 64 divided by 2. This is a 32-degree angle. Okay. Now from there, again, both of these are congruent. Isosceles triangles. So if I take 180 minus 72 minus 32, I get 76 degrees here and 76 degrees here. So to get x, I can take 180 minus 76 minus 76. 152 from 180 would be 28. So I'm going to go with C. Okay. The next one, we've got these two triangles that are, we're going to determine whether the triangles are congruent, and we're going to use it using rigid motion. So as I look at this, it looks like a translation to me. So if I'm going to go over 1, 2, 3, and up 1, 2, 3, 4, 5, 1, 2, 3, 1, 2, 3, 4, 5, 1, 2, 3, oh, hold on, what did I do wrong? 1, 2, 3, oh, it should be 4, sorry. 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 7. There you go. No, it should be corresponding points. Hold on. So 1, 2, 3, 1, 2, 3, 4, 5. Good. 1, 2, 3, 1, 2, 3, 4, 5. We're good. And then this point, 1, 2, 3, 1, 2, 3, 4, 5. And I got confused with that point right there. But I'm going to say that I can translate each of these points, translation. We're going to go, what did I say, 3 to the right and up 5. Let me just double check that here. 1, 2, 3, 1, 2, 3, 4. Yeah, 3 to the right and up 5 would be the translation that we could use. Each one of those is translated the same amount, so the figures are going to be congruent to each other. Okay? All right, let's on to the back side now. All right, now, here's what I would tell you. I meant to go ahead and write in these letters here, and I didn't before they hit the presses, so I need to go ahead and do that now. Okay, so basically we want to determine if they're congruent or not, and then write the congruency statement. So I'm going to go ahead and do this. I'm going to do the reflexive property there, and then I'm going to go ahead and say, yeah, triangle ABC is congruent to triangle DBC by angle, side. Okay? Again, the reflexive property for number 10, I'm going to say triangle ABC is congruent to triangle ABC would be CDA. This one is by side, side. Okay? This one also has the triangles congruent. ABC is congruent to triangle DBC. Or you could put DCB because it's an isosceles triangle. You can go either way. So again, ABC is congruent to either DBC or DCB. And again, this is side, side. Okay? And the last one, triangle ABC, is congruent to triangle DBC by side, angle, side. Okay? All right. Number 13, the Amelia cuts out an isosceles triangle, RST, excuse me. She folds a triangle so that RS lies along RT. So this segment lies along this segment. Then she unfolds a triangle. Naomi claims that the two smaller triangles formed by the crease are congruent by HL. Do you agree and explain? Well, if I show the crease, it's probably going to be somewhere right in there. And I am going to say that these angles are going to be right angles because it divided them evenly. And I'm going to say that this is congruent by the reflexive property. So I'm going to say, yeah, you could prove triangle RST, I'll put U. Triangle RSU is congruent to triangle TSU by a hypotenuse leg. Okay? That would be possible there. All right, now numbers 14 and 15 down here. If I go ahead and show that this is the length of A and this is the length of B, equal but in the opposite, this is negative B. So the ordered pair here is A, negative B. This one is equal but in the opposite because it's centered at the origin. So negative A, positive B. This is negative B, so this is negative A, B. And this is negative A, negative B. Okay. This one's a little bit harder. This one is B, comma, C. So if we do that same triangle right over here, this would be a length of C, and this would be a length of B. So to go from the origin to this point, I have to go over and then up. I'm going to have to go over S, that's to this point right here, and I have to go over B more. So the first variable is S plus B, and I'm going to go up C. Okay? S plus B, comma, C. All right, number 16. Last one. We got a proof here. And here's what I'm going to do. I'm going to write down XY is parallel to WZ. Okay? Now, what does that mean if XY is parallel to WZ? What that means is that these alternate interior angles right here and here have to be congruent. So I'm going to put down angle 2 is congruent to angle 4 by the alternate interior angles theorem. All my shorthand. Okay? Now we're also told, as part of our given, that XW is congruent to YZ. So if I go ahead and do XW and YZ, well, they influence these other angles, 1 and 3. So, again, that was given. So for number 4, I'm going to say angle 1 has to be congruent to angle 3. By the same reason as number 2. Okay, we also have the reflexive property taking place here. So XZ is congruent to XZ. Okay, and after that, I would then know that triangles are congruent by what's called angle, side, angle. Angle, side, angle. So I'm going to say triangle WXZ is congruent to YZX. by angle, side, angle. Okay? And if the triangles are congruent by angle, side, angle, these segments, XW and YZ, have to be congruent. By CPCTC. Okay? So, I know that was really fast. Again, I don't want to make this a longer video than I have to. So, if you have questions there, folks, let me know. Otherwise, be prepared for the test when you come to class. Thanks for listening. Good night.